All right, so now here on example 3, we're going to be working with an equation that has purely imaginary solutions. So the equation x squared plus 81 equals 0. We know this is not going to have any real solutions because if you look at this, x squared would need to equal negative 81, which means that we would have to find a number that squares to be negative 81. That's not going to be a real number, it's going to be an imaginary number. We're going to be thinking about this as a quadratic that does not touch down, but instead crosses through 81. Okay, 81 is the minimum value of this quadratic. We have x squared raised up to 81. Okay, so this quadratic never touches down at y equals 0, which means we have no way to say at a certain x value our equation equals 0, because our x-axis only represents the real numbers. It only goes from negative infinity to positive infinity. And what we need is an imaginary solution. So it's not going to appear on this graph because this graph is defined only as two sets, the x set of real numbers and the y set of real numbers and all of their combinations. But that is not what we're looking for. So what we're looking for, we will find by hand. Okay, if we have x squared plus 81 equals 0, let's just go through some arithmetic steps here to get a solution. We will first take away 81 from both sides. We will then take the square root of both sides. From there, it is following the kind of examples we did before, where we take out that square root of negative 1, simplify it down to I, and then we will have the square root of 81 remaining. Now, the square root of 81 has two values, positive 9 and negative 9, which means our final solution is plus or minus 9 multiplied by I, plus or minus 9I. Okay, that's kind of the quick one. Now, there is an alternative method that we can use that's a little more interesting to me. It's also much more complicated. So strap in and pay attention on this one because we're going to be talking about something that you may or may not have seen much of. So what that is the difference of squares. The difference of squares is a pretty cool idea, really. Let's take kind of a step to the side first. So I want to talk about operations, adding, subtracting, multiplying, dividing. Now, there are operations that are related to each other, like addition and subtraction are kind of equal and opposite operations. Multiplication is repeated addition. Division and multiplication are opposite operations. So there are relationships between the operations we do. There is a relationship that exists there that is not obvious at all, but it's that subtraction can be written as multiplication. Okay, so that should sound a little weird. The difference between two numbers could also be written as the product of some numbers. And we'll see how that works. So first of all, let's maximize this little screen over here so we can see as much as possible. Okay, so first of all, let's just go at that again. Say that any number can be written as some other number squared. So if I have 4 times 4 and I have an area of 16 here, I can say 16 is just 4 squared. Okay? It's just the square root of 16 squared. Now, we don't need to have perfect squares for this to be true. Let's say we have 4.5 times 4.5. Well, that gives us an area of 20.25. 20.25 is just the square root of 20.25 squared. Okay, so any number can be written as its own square root squared. Now, with that in mind, we are going to talk about a subtraction problem where we have x squared minus a squared. That is going to be our problem, x squared minus a squared. Okay, so I've got a series of pictures here for you. Come around this side. So first of all, we have x squared. Okay, x times x makes x squared. It's going to be this large square here. This dotted square just represents that x squared, so you can see that a squared is something smaller. Okay, a squared is a by a. Now, if I want to say x squared minus a squared, it could be this picture here, the larger square with that little one missing. So this would be x squared minus a squared. That would be a subtraction image of this expression. However, I want to turn this subtraction image, where we have this kind of weird, square with a bite out of it, into a multiplication image. So the way that I'm going to do that is I'm going to take this little rectangle here. If you think of a larger rectangle and a smaller rectangle, I'm going to take this one here, just drawn by this little dotted line, and I'm going to move it to the right side. So we're going to take this and we're going to move it up here. Okay? So what that means is that when we move it, we have a new image here. We have a side length of x plus a, because we took this little length a and we rotated it up there, so that a is now up here, x plus a. And this one that used to be a full x has now lost a length of a, so we have x minus a, which I wrote on the right side. Okay, so now we have the multiplication of x plus a times x minus a. We've taken a subtraction and we've turned it into multiplication. Okay, so visually, that is what is happening when we do something that's called the difference of squares. Now, let me give you an example of that without representing those areas as little bites out if they're negative. We're just going to keep track of the value of numbers. Okay, so let's look at this one, x squared minus 81. So we're saying a subtraction problem. We're going to turn this into two squares. So x squared is already a square, but we're going to think of 81 as 9 squared. So we have the difference between x squared and 9 squared. The way that we get that is by doing x plus 9 times x minus 9. Just like before when we did x plus a times x minus a, here we end up with x plus 9 and x minus 9. So our x's make x squared, our 9's make 9 squared with a negative in front. We get negative 9 x's in this box, positive 9 x's in that box, which cancel out, leaving us with just what we wanted, x squared and negative 9 squared, or negative 81, the expression at the beginning. So we've taken this subtraction and we've turned it into the multiplication of x plus 9 times x minus 9. Okay, our zero product property tells us that the only way for this product equals 0 is if the left or the right side equals 0. So we can do that by making x negative 9 or this second x positive 9, okay, meaning our solution is plus or minus 9. The problem that the book had that we were looking at is very close to that one. However, instead of a difference of two numbers, it's the sum of two numbers. It's not x squared minus 81. It's x squared plus 81. However, we know that addition and subtraction are related. So we can just say, well, if we want it to be a difference, let's say it's minus negative 81 instead of plus 81. Okay, now we have a difference. Okay, we have x squared minus negative 81, 9 squared there. Okay, so if we go to our box diagram, we could say we would get that by producing a diagram that looks like this: x plus the square root of negative 9 squared and x minus the square root of negative 9 squared. I didn't fill in these boxes because they were going to get kind of big, but these two boxes are the boxes that always cancel out with each other because we have the positive one up here and the negative one over here. These two together, the negative sign remains, and we have the square root of a number times the square root of a number. Those square roots go away, and we just get the negative 9 squared in there. So we get the amounts that we're looking for, which means that this addition problem, which we turn into a subtraction problem, can now be written as a multiplication of x plus the square root of negative 9 squared times x minus the square root of negative 9 squared. Okay, our zero product property would tell us that this x could be negative the square root of negative 9 squared, and this one could be the positive square root of negative 9 squared. So we have plus or minus the square root of negative 9 squared. Our final step would be to break this apart into factors. So we could say that is the square root of negative 1 times the square root of 9 squared. Square root of negative 1 becomes our I, and square root of 9 squared just becomes plus or minus 9, giving us our same solution there of plus or minus 9i.